All right, so before you left from the morning session, we were looking, well, I placed this question on screen and you were supposed to work on it during the break. I am seeing where some persons place their answers in the chat. I'm seeing 98 degrees for M, and I'm seeing 49 degrees for the angle identified as N, as in no. And I'm seeing some explanations, which is good. Really nice. All right, we'll have some more time to practice this theory. So if you got M to be 49 by simply multiplying by 2 because the angle at the center is twice the angle at the circumference, awesome. And if you identified angle N as 49 degrees because the angle subtended by the same chord, by the same chord, well, technically arc as well, but by the same chord, in the same segment, they are equal. So good job for those who went ahead and got those answers. And if you didn't get it on this try, it's okay. You're gonna get it on the next one, I'm sure. All right, so now who is ready for the big bad CSEC questions? If you're ready for a big bad CSEC question, type ready in the chat. Or let me see some emojis popping up, like the thumbs up emoji, excited emoji. If you're ready for a big bad CSEC question, let me see you say ready in the chat. Ready and rearing to go. There's only one person ready? Then this not look good. Okay. Oh, you were taking some time to type already. Okay, got it. All right, no problem. I'm moving up. All right, ready is with 4 Ys, Sharika. Ready with 3 Ys, Cheyenne, Burke. All right, so you ready. These ladies are ready. Rashida had 2 Ys. So Rashida ready? Well, Sharika ready. All right, here we go. So I'm placing this question here. So in this diagram, you're seeing angles A, B, C, D, or their points actually, my bad, on the circumference of this here lovely circle with center O. As you can see, angle AOC, AOC and BOD are diameters, and AB, line segment AB and DC are parallel, which are indicated by the little arrowheads. So when you have arrowheads on your line segments, that's an indication that they're parallel. Okay, not because they look parallel, we're assuming that they're parallel. Parallel lines normally have, or line segments normally have arrowheads on them. First question, give me the reason why angle ABC is a 90-degree angle. No man, Danny, quick man. Danny, before I even say angle 90 degrees, I should have even said, Danny, I saw your hand. Go ahead, sweetheart.
Right, so this is not the rule word for word, but what I remember is that once the angle is on the diameter, because we have the diameter, which is AOC. So since the angle since the triangle is using the, once it's on the diameter, then the point on the circumference would be 90 degrees.
All right, I'll take that. So you're saying that the angle formed or subtended by the diameter and the angle at the circumference is or will be 90 degrees. All right, I'll take that, I'll take that, I'll take that. All right, anybody else would like to share? Oh, I'm seeing some answers in the chat. Angles forming the semicircle. But angles formed where? You have to tell me at the circumference. You have to, because remember, you know, we can form angles inside of the circle independent of the circumference. So you have to tell me the circumference. All right. Selena, right angle is not an acceptable response, because how you know that it's a right angle? How? That's what we want to know. How? And that is because the angle is formed at the circumference in a certain semicircle. Or you could even give this the explanation that it is half the angle at the center because it is subtended from the same chord AC. So we could do that. So semicircle, diameter, circumference, any of those will work. All right. Alrighty. What about angle BAC? Let me highlight angle BAC just in case you're not able to see angle BAC. So we know that the letter in the middle usually indicates which angle we're referring to. So you just run your finger over your paper or over your screen, start with the first letter and make your way down. So starting at B, angle B, A is here, and C comes down here. So we need this angle here that is labeled 2P degrees. Gonna give you a minute to work on that. We need to know what is the value of the angle marked 2P degrees. And if you notice, we have a little algebra coming in. I know that some of us, when we finish with the algebra concept in class, we think we're finished with algebra. Algebra can come in so many different questions on your CSEC paper. You will not only see algebraic concepts under the question that is specific for algebra. It can come anywhere. It can come in your measurement questions, can come in your geometry questions. So it's not only for the algebra concepts, can come elsewhere. So you have to love algebra, fractions, decimals, those keep coming back. So you have to be really comfortable with those concepts. Even if you don't have the final answer, anybody would like to explain to me what's the thought process that you're having with trying to figure out the actual value for angle BAC?
Miss, can I?
Go ahead, Rihanna.
Okay, so from the previous question, we can see that B is equals to 90 degrees.
All right, let me put that in. By the way, I hope you guys are sketching your diagrams in your books.
So we can say that 90 degrees plus 2P plus 3P equals to 180. degrees
Why 180?
because a triangle measures 180 degrees.
The triangle measures 180? What part of the triangle measures 180 degrees?
The angles.
Thank you. The
Angles
angles where?
measures 180 degrees.
Which angles? Can we have different types of angles, inside, outside,
The
roundabout side?
total angles in the triangle equals to 180 degrees.
Okay, the interior angles. Yes, Sudi. All right, continue with the third process.
So I can say 90 degrees plus 2p plus 3p equal to 180. And we can carry over the 90 and say, or subtract both sides from 90 from both sides.
Thank you very much.
And that will leave you with 2p plus 3p equals to 90.
All right.
Then you add up the like terms, aka the 2p and the 3p, that will give you 5p. And to get p alone, to get the value of p alone, you divide both sides by 5. And that will give you 18. And then to get 2p, you multiply 18 by 2 to get 36 degrees.
Wonderful, lovely. Thank you so very much, Sister Rihanna. You're over there, work, man. Love that. Love that. I don't think I can say it any better than Rihanna. But did I lose anyone? Because remember, we're not leaving anyone behind, no man left behind. That's the goal for today. No man left behind. Okay. All right, so let me address the first question is, how comes B is 90 degrees? That's the first question. Can somebody help Moses in understanding how comes B is 90 degrees? Not Danae, not Rihanna. Can somebody else help Moses to understand how comes B is 90 degrees, please? By opening your mic and sharing.
It's because angles in a semicircle made by the diameter and touching the circumference is equal to 90 degrees.
I couldn't say it any better than Michaela. Thank you so much, sweetie. Moses, you hear that? Awesome sauce. All right, so let's go back now to how now we get the value for 2p. So the first thing Rihanna identified is that there is a triangle in play. And we know that the sum of the interior angles of a triangle is 180 degrees. So all we need to do is write an expression with the values that we have to show that the sum of the interior angles in a triangle sum to 180 degrees. And that's what we did. Angle 2p plus the 90 degrees plus angle 3p is equal to 180 degrees. That should be clear. Then the next thing we're going to do, and you don't have to do it in this order, but based on what I have written on my screen, I grouped my like terms and simplified, right? So 2p plus 3p, that is 5p's. Not 5p squared, but 5p. All right? The next thing I'm going to do, I remember I need to get p by itself. So first, I need to get rid of the 90 degrees. So I'm going to subtract from both sides in an effort to get rid of my 90 degrees. Remember, anything you do to one side, you have to do to the other side. And that's what I did. Now my oops, so my 5p simplified is 90 degrees. Now I need to get p by itself because that's the aim. P is being multiplied by 5 in this case. So to get rid of that 5, I need to divide both sides by 5. 180 subtract 90 would have been 90. So when I divide 5p by 5, I get p alone. Now I'm dividing my 90 by 5. Simplified, that is 18 degrees. However, angle BAC is 2p. It's not just p alone, it's 2p. So for me to completely answer the question, I now need to multiply that value of p by 2 because the angle is being represented as 2p degrees. And that's what we did there. And 2 multiplied by 18 is 36 degrees. Are we all on the same page now? For those of us who were not on the same page, are you here with us now?
Yes, miss.
All right. Moses, or you stay? Javon, or you stay? Awesome sauce. Great. Daniel, you get in there. All right, not a problem. As long as you're coming, no man left behind. All right. What about angle Q? Angle Q. This one is pretty easy. Terry's, how comes? You can go ahead. Janice, you can turn on your mic and ask the question. I'll take your hand, Danny. Hold on. Well, let me hear the question from Janice.
Okay, good morning.
Good morning, sweetie. Afternoon, actually.
Okay, good afternoon, my bad. For the question before, where it had the 90 degrees at the top.
You're asking if the question came with the 90 degrees?
No, miss. I'm saying that the 90 degrees at the top, I was wondering why couldn't it be like at the center? Because I just came and I heard that where the diameter and the line adds up to 90 degrees or something like that.
Okay. All right, no problem. All right, so you weren't here this morning, darling?
No, miss.
Okay, all right. Oh, you missed the foundation, man. Because what we're doing is actually working a question based on what we did this morning. All right, no problem. I'll see if I can catch you up to speed. So, when we have an angle being formed at the circumference tending from the diameter, it automatically forms a 90-degree angle. So the line segment AC, which is automatically the diameter. Where's my laser? See my laser here. Can you appreciate that AC is the diameter? O is our center of the circle. Can you appreciate that AC is the diameter?
Yes, miss.
Great. So we have a theory that says any angle formed at the circumference where the arms of the angle, which would have been the line segment AB and BC, are coming from the diameter, automatically that angle at the circumference is a right angle. Can you appreciate that?
Oh, yes, miss. I just understood.
Awesome. So if say for example, let me try to sketch one. If I created an angle right here, so, and come right here, so, oh, that is not straight, please forgive me. This angle will automatically be 90 degrees because it was formed from the diameter. So any angle formed by the diameter at the circumference or from the diameter at the circumference, automatically it's a 90-degree angle.
Okay, thank you.
Yes, so that's how we got the 90. So from understanding how we got the 90, is everything else clear?
Yes, miss.
Okay, awesome sauce. All right. Oops. I hope that everybody else is right where I'm at. Rashida, is it a question or a comment? So you're asking if A, B, C, and I want somebody to help me help Rashida. So she's asking if the angle A, B, C and angle B, C, D is tending from the same chord and in the same segment. Anybody would like to take on that question? Is angle A, B, C and angle BCD tending from the same chord and in the same segment? Anybody want to take on that question? Nobody? Can Blake trying? Denisha, you trying? Or your mic accidentally open? Okay, here's my question. What do we use to create our segments? What parts of the circle do we use to create our segments? Anybody can answer that question. A chord is technically two things, an arc and a chord. Thank you, Ashley. An arc and a chord. All right.
Miss,
Yes, there?
question. The
Go
card
ahead.
is used to create the segment, right?
Mm-hmm.
And the
An
arc is
arc
also
and
used to create the segment?
yes. So look at my screen. So going along the circumference, we have the arc AC or ABC, but we can't even bypass the angle AC or ABC. This is an arc, yes? And our
Yes,
chord
miss.
would be AC. Also, I'll have to include B. So our arc is ABC and the chord is AC. So we have all of this to be one segment and all of this to be another segment.
Okay, miss.
So because the diameter in this case is acting as the chord, we basically have two half segments that we call semicircles. So technically we don't have a major or a minor segment because both of them are the same size. Now, so the diameter in this case is acting as the chord for this angle ABC. Let's look at the angle BCD. What is the name of the chord that BCD is subtending from?
BD.
BD or DB, whichever you choose. Yes. So my question is, are the angles ABC and BCD subtending from the same chord? No, they are not. Because angle ABC is subtending from the AC chord, while angle BCD is subtending from the BD chord. So they are not subtending from the same chord. And if you notice, these two chords are special chords. I hope I answered your question. I don't remember who asked the question, you know. Rashida. Rashida, answer your question today. Awesome sauce. All right. So we're still working on angle Q. What's the value of angle Q? Which is this angle right here. What's the angle and what's the reason? Remember, we always give a reason. CSEC will require you to give a reason, and there's a mark allotted for that reason. If you cannot say what the reason is, you are giving away your marks. And that is one easy free mark, so I don't want you to give it away. Samsung SMA125F. I would really love if you could rename your name so I know what your actual name is, so I can call you by your name. If you're having trouble renaming yourself, just send a private message to Mr. Limi and he will assist you with that. I want Rashida and Akila to tell me how they got 90 degrees.
Miss, any angle formed at the circumference coming from the diameter is 90 degrees.
All right. I'm very happy you said that. And I noticed that there are other persons who are also saying 90 degrees. So here is my diameter, right? This is my diameter, right? BD. Right, Akila? Hello? Hello? Where Akila went? Let me see who else. DeAndre, do you agree or disagree that BD is my diameter? You disagree that BD is the diameter? Okay, so which one is the diameter? Is it BC or DC? AC is another diameter, yes, I agree to that. But if you're going to tell me that the angle at Q is 90 degrees and your reason is because it is subtended by the diameter, then Q has nothing to do with AC. It comes from C, but not AC. So BOD is indeed a diameter, as well as AOC. So if BOD is the diameter, is angle Q formed from the diameter? Is angle Q formed from the diameter? I need somebody to answer that question. Is both arms of the angle subtended from the diameter? Nobody not answering the question that I'm asking. for angle Q, are both arms of the angle that forms Q, which is this arm here and this arm here, are both arms subtended from the diameter? Okay, thank you, Rihanna and Alyssa. No, it's not, which means that the theory about the diameter and the angle at the circumference cannot be used. So I'm seeing some person saying 36 degrees. Can somebody share with me? I think I want to take Timari Hutchinson's response as to how, I'm assuming that's a he, got 36 degrees. Remember, you have to give me a reason. Timari?
I send the, mic isn't working for the person.
Oh, the mic isn't working. Okay. Danielle? You can type it though in the meantime, Timari. Danielle, can you give me a reason how you got 36? No, Danielle, it's a wrong something. Let me tell. Moses. But which answer you got, Danielle? But Moses, tell me how you got 36. All of a sudden, everybody working that mic now work. You see, understand? Yes, Daniel, you. What is the value you got for Q? Go ahead. So let me read. I'm gonna allow you to go ahead, Michaela. But I'm seeing where Samsung, you still don't rename yourself yet, so I don't know who you are. But this person is saying angles in the same segment of a circle and are standing on the same chord are equal. Mercedes also said that because they're in the same segment and they're subtended by the same arc, they're equal. Question, what's the name of the chord or even the arc that angle Q is being subtended from? What's the name of the arc or the chord that angle Q is being subtended from or subtended by? BC, lovely. Here it is, arc BC. Whether you say arc or you want to use the chord, which is the portion of the circumference, either one works. But it's BC. So you see that angle Q is coming from the chord or arc BC. We also see that angle 2P is coming from the same arc or chord. 2P is also coming from the same arc or chord. We already know the angle for 2P, which is 36 degrees. And we remember that when we have angles subtending by the same arc or chord in the same segment, those angles will be equal. All right. Hope I didn't lose anyone there. What about angle R? Angle R. R is what we're doing next. Okay, no problem. I can do that for you. I keep losing my my cursor. So right here is 36. Boy, this thing you're not writing so lovely. Right here is also 36 degrees. So we know that. We know that those are 36 degrees. What about R? R is very easy. You're welcome. Very, very easy. I'm seeing one response thus far. Please ensure that you're sketching these questions in your books, so you have them for reference when you're practicing for your exam. You can't just give me a number, you know. A. Smith, DeAndre, George, Collins, Danny, where's the reasoning? And 36 what? Come on, guys. Let's not forget our units. Chriselle, how comes it's 36 degrees? What's the reasoning? Don't just put a number, I need a reason. Go ahead.
Angle C is...
Angle C or angle R? There are two angles at angle C or at point C.
Angle C on a whole is 90 degrees because it's opposite of the diameter, and we already found out that P is 18 and 3P is 54. And since angle C is 90 degrees, you just have to minus the 54 from the 90 degrees and you get 36. So R is 36.
Okay, that's one way. That's 36 degrees. Love that. That's one way. Danny, what are you talking about? Angles on an alternate angle are equal. Oh, alternate. Okay. Z angles. Got it, got it, got it. All right. I didn't even see that. Great. So those two responses, I wasn't even thinking of those for my answer. See, that's good. Okay. Lovely. I still don't hear my answer yet though. I'm waiting on my answer. I didn't even realize the alternate angles, and I wouldn't have gone the route of the 90 degrees either. Anybody else is not? What happened to all the other persons who said 36? What's your reason? Angle C is 54. Which part of angle C is 54, Rashida? C and R are not on any straight line, my dearest. What straight line? I'm not following your explanation, Rashida. Okay, so 3P and R, that's not a straight line. I don't know who was talking to me just now that they share that that's a 90-degree angle, because it is an angle that is subtended by a semicircle at the circumference. So that's automatically a 90-degree angle. It's not a straight angle. Remember, we discussed straight angle already, you know. Has to be a straight line segment, and then we have adjacent angles on that line segment. There's no straight angle at C. Alyssa and I are having the same thought process. There is a triangle, and let me go ahead and label my triangle. Let me me erase first and erase that. So there, something interesting. There is a triangle DOC. And this triangle is an isosceles triangle because it is formed using two radii. By virtue of that, the base angles are equal. So if Q is 36 degrees, automatically R is also 36 degrees. That was my reasoning. But your other reasoning is quite fine. So there, you see, there is always more than one way to find an answer. So that was good. That was really good that we found 3 different ways. I love that. Not mad at it at all. All right, so let me write in that. Did I lose anyone? We're all still together? All right, Rashida is asking me to say it again. Not a problem. So there is an isosceles triangle formed, and we can call that isosceles triangle DOC. You see, I highlight it in green, DOC. OD is a radius. OC is also another radius, which means that this triangle is an isosceles triangle. For isosceles triangle, we know that the base angles are equal. Those base angles are identified as Q and R. We know Q already to be 36 degrees, which means that R is also 36 degrees. Fine, you're back now, Rashida and Moses. Nobody look here, try make your brain come back. Come, nobody make your brain go too far. And this is the easy part, you know? What you gonna do when you get to the hard part? Come, try bring back your brain. Okay, good. Easy part is crazy. Nah, fam. This is the easy part. All right, so you saw my isosceles triangle though? All right, Rashida is back. Great. Moses, you saw my isosceles triangle? If you don't see the isosceles, you know it, all right, good. But there were also other ways. We got the Z angles and we got the 90 degree in the semicircle. So any of the 3 ways is great. There is no one way, all right? You don't have to use my way. Your way is fine. Sorry for your situation. Very sorry for you, sir. Okay, that assist you. All right, so come now. So we know that R is 36. Remember, I was telling you that one strategy to help you is to, as soon as you find an angle, you write it in. So when you have to calculate the other angle, you have the previous information already on your diagram. All right. Oh, wait. So, all right then. What about 3P? 3P was not a part of the question, but I'm going to go ahead and ask. If you were listening, somebody had asked already, but I'm going to ask anyway. What is 3P? I don't want the person who explained to me what 3P was to say it again.
54 degrees.
How you get 54? Is it Anna? Anna?
Yes, miss.
Okay, how you get 54 there?
It's from our previous working out when we were finding 2P. We found out that P was equal to 18, and to find 2P, we had to multiply the P by 2. So I assume to find 3P, you have to multiply the P by 3. And since the P was 18 and you multiply 3 by 18, you get 54 degrees.
Excellent. Lovely. Wonderful. And I'm seeing somebody in the chat say 90 minus 36. So if you went ahead and found the value of R first, and you know that R is 36, you could just go ahead and subtract the 36 from the 90. So either one works. Awesome sauce. All right, for the person asking, Kate, the recording, sir would have said that the recording would have been available by this evening or no later than tomorrow. Because remember, after we're through, it takes a while for Zoom to download the thing and put it together. So it should be up no later than tomorrow morning on our YouTube channel. All right. All right, so I wanted to just breathe in, breathe out. Breathe in, breathe out. What's that? All right. Ready again now. Ready up again? So we're going to take a quick recap. And this easy. We know this already. Come. Just roll off angle B. Quick and fast. What's the value of angle B?
$50.
50 degrees.
Tell me how you get that. Mr. Gentleman, sir, I've asked you to change their name in Zoom about 3 times already. Change your name, Nabasi, please. So I can address you by your name and not the type of phone
Miss,
you're
me no know for
using.
the miss.
Message Mr. Lee privately and he will do it for you. You know how to do that? Or just put your name in the chat. Put your name in the
And
chat.
put the name in the chat and I'll just do it.
Put your name in the chat and Mr. Lee will change it for you. Because I want to call you by your name. I like to call people by their name so I know who I'm talking to. All right, tell me how you get the 50 now. Anybody can tell me, explain to us how you got the 50. Go ahead, Torian. First time seeing Torian raising her hand. Go ahead, my darling.
So our given angle is 40 degrees. And up top, we're seeing a right angle. So I know that right angle is equal to 90 degrees. So 90 degrees and 40 degrees is 130. And then I'm going to subtract 130 from 180 degrees, which is the total, what should I say? All degrees in a triangle should equal to 180. So subtract the 130 from the 180 to get 50 degrees.
All right, thank you, sweetie. And I see some of you in the chat would have had that same explanation. Awesome sauce. What about, we know this, come on, tell me quick. I'm not even going to ask you how you get it. Just give me the value for B real quick. I love the use of the
70.
language. All interior angles sum to 180. Excellent. Sorry, go ahead. Lower your hand, Tori, sweetie.
Miss, I was saying 70 degrees.
70 degrees. And I see the chat. 70, easy. That Moses said. All right, good. Lovely. Wonderful. All right, so it's about angle D. Definitely need the reason for this one. Rashida, where are co-interior angles formed? What's the criteria to have co-interior angles? And remember, you have to tell me a reason. Two-point separated by a line segment. Rashida, is where you learned that. Don't tell them say, is me sure I teacher that you know? Parallel lines and the transversal, Rashida. Is that Aline? With a raised hand?
Yes, miss.
Okay, go ahead, sweetie.
So I chose 130 for my answer because all the angles in the quadrilateral should equal to 360, and 120 plus 60 plus 50 is 230. So I subtracted 230 from 360 and got 130.
Thank you, my darling. What 130 what, please?
130 degrees, sorry.
Thank you very much. All right. And I'm seeing most people having 130 degrees, and you were subtracting from 360 degrees, sorry, 360 degrees. All right, awesome sauce. Now I am going to do a demonstration like I did previously, and I want you to observe and tell me what you notice. Are you seeing my screen?
Yes, miss.
You seeing a quadrilateral on my screen? In a circle? That's what you're seeing?
Yes, miss.
Yes, we are.
Okay. Okay, awesome sauce. Okay, I'm trying to zoom it on up. All right, this is as big as it gets. All right, tell me what you notice. Mercedes, go and look, man. You notice something already? You noticed it a while ago, or you didn't know from a long time?
Yes, I know.
All right, let us give the people who don't know a chance to notice. Tell me what you notice, young people. Even though the answer is on the screen, if we're not reading. All right, Mercedes, go ahead and tell me what you notice.
Opposite angles in a circuit quadrilateral are always supplemented, which means they add up to, and everything together with add up to 360.
All right, so Mercedes said that. By the way, this is called a cyclic or cyclic, either one works. Quadrilateral, which is just a quadrilateral within a circle. And Mercedes is saying that the opposite angles and opposite meaning over here so and over here so, okay, across from each other, the people who are the angles that are facing each other, that's what opposite means. The opposite angles sum to 180. Anybody having an issue with that? And they are supplementary. So when two angles sum to 180, we call that supplementary. So anytime you see the word supplementary, it is suggesting two angles sum to 180. Everybody can appreciate that? Who never see it? Who didn't see it? All right, I'm assuming everybody saw it. So when we have a quadrilateral where its vertices are touching or lying on the circumference of a circle, we know that the opposite angles, as you can see on your screen, and I'm going to label those angles, I'm going to get some new letters now. It's either A and B, X and Y. I'm going to say X and Z. X and Z are opposite and they are supplementary, which means that they sum to 180 degrees. That's it. Nothing about it other than that. One of the things though is that sometimes you see like how this one it kind of look like a triangle, but it actually see 2 points right here, sir. Sometimes you have to really look because sometimes the quadrilaterals are formed, but they kind of look weird. So you have to really pay attention to your diagram and ensure that you identify the right stuff. All right. So I want you to look at this diagram, typing in the chat using 4 letters. Can you identify any cyclic quadrilateral or cyclic quadrilateral in this diagram? Using the 4 letters, type in the chat. And I'm just going to go ahead. Type in the chat. All right. So I'm seeing ACDE, ACDE. I'm seeing BCDE, BCDE. All right. So if you had BCDE as one or ACDE as another, or any arrangement of those letters, doesn't have to go in the same order, any arrangement of those 4 letters, then you are correct too. All right. So quick and fast, just try it out quickly. What is the value of the angle marked X?
Miss 50.
Miss 50 degrees.
Oh, something no, man, I have to talk like on a sure, man.
50 degrees.
50 degrees.
Yeah,
Miss,
talk
it's
with your
50
chest,
degrees.
man. Talk with your chest, like you're sure. Why is it 50 degrees?
Miss, they must add up to 180.
Why?
They're supplementary.
Very good. That's it. Opposite angles in a cyclic quadrilateral are supplementary. Fabulous, fabulous. All right. Now, listen up, you know. All right. So separate and apart from the fact that the opposite angles are supplementary, there is also the fact that the exterior angles is equal to the interior opposite angle. Let me say that again. The exterior angle in the cyclic quadrilateral or cyclic quadrilateral is equal to the interior opposite angle. Now, I want you to look at the diagram on screen and tell me which 2 letters, first of all, which letter is the exterior angle? In this W. Fabulous. The one where the outside, okay, of the quadrilateral. And then which angle would be the interior opposite angle?
X.
X.
X. Fabulous. without even, what other, can I say, theory or property based on this diagram we can use to know that, yeah, man, true, this is true? Based on the diagram that you're seeing, what can also confirm that X and W would be equal? Anybody want to take a guess? Devin, I don't know if you want to talk to us, but your microphone is open. Go ahead, Danny.
Miss, that when you look at X plus Y and Y plus W, both of them are supposed to be equal to 180. So that once you already know what Y is, X and W would be the same number.
Yep. Because what is specific to Y and W? Why Y and W would sum to 180?
Miss, because it's on a straight line and angles on a straight line is equal to 180.
And we said we were going to add a particular word this morning about those angles. Adjacent angles on a straight line. Very good. So it's not make up story. We already know that the adjacent angles on the straight line sum to 180. So as Danny said, automatically we also know that the opposite angles sum to 180. So if these two things sum to 180, we know what Y is, automatically the other number will be the same for W and X. Remember though, it has to be 2. So it's not, it couldn't be X, Y, and W. So say for example, let me just drop this in. I feel the need to say it. Say for example, we had another angle here. And say this angle was angle C. And this was angle D. C and D would be the same as X. It has to be all of the exterior angles. You understand what I'm saying? So it has to be the entire angle that is formed on the exterior, even if it is separated into 2 angles. Does that make sense?
Yes, Miss.
Okay. For the other people in the chat, does that make sense? Okay, awesome. Zara is saying no. All right. So what I'm saying, Zara, let me clear my thing. The theory is angle X and W will be equal because the exterior angle represented as W here and the opposite interior angle in a cyclic quadrilateral are equal. We also confirmed that X and W will be equal because Y and W are adjacent angles on a straight line. But I am saying to you that is this entire space on the outside here that will be equal to X. So in the event there is another angle and we have 2 angles being on the outside, both angles is what will be equal to X and not one of the angles, because it's the entire portion. So if CSEC gives you a question or miss at school and the angle on the outside is now split into 2 angles, so we now have 3 angles on the straight line. All of what is on the outside of the quadrilateral is what is equal to the value of X. Is that clearer for you, Zara? Okay, good. Remember, no man left behind. Awesome. Is there anybody else who is unclear? Removing all of my ink. All right. Doing another demonstration. I hope you're making a little notes, Doing another demonstration. So just look at your screen and tell me what you notice. Quick question. What do we call the line segment BC, or that entire line going through BC? What do we call that? Tangent. Very good. Tangent. And what do we know about a tangent? What makes it a tangent?
It only touches 1 point on the circumference.
It only touches 1 point on the circumference. Excellent. All right. So tell me what you notice happening in this diagram here, so now. What's happening?
Miss, when it's touching the tangent, it is the 90 degrees form.
When what is it? Be more specific.
Miss, the radius.
Talk like you're confident, no, girl. Talk with your chest, man, like you know what you're saying.
Miss, when the radius is touching the tangent, it's a 90-degree angle is formed.
All right. Moses, what you saying? You see, fling down back your hand quick enough. Put it up back, man. What you saying? No bother with that. Come, tell me what you say.
Miss, are you hearing me?
Yes, I am. Loud and clear.
I was saying that when a chord that is subtend from the center of the circle to the circumference where tangent is formed, angle of a 90 degrees is formed.
All right, you said when a chord is AB a chord.
It's a radius.
Okay. So when the radius, go on again.
When the radius is formed from the center of a circle to the circumference and it touches a tangent, a 90-degree angle is formed.
Lovely. Lovely. We don't have to say it one way. Anywhere you can say it, that's fine. So when we have a radius meeting a tangent, they form a 90-degree angle. There's a P word that we use in mathematics when two line segments meet and form a right angle. What's that P word?
Perpendicular.
Perpendicular. Come true, Yendi. Perpendicular. Yes, Tikwan and Odena. If I am not pronouncing your name right, I sincerely apologize. Yes, perpendicular. Fabulous. Excellent. Love it. See, when I know the things that man and I must talk with the chest like when I believe what I'm saying. All right. So at our point of tangency, which is when the line segment, at that point that the line segment touches the circumference, we have a special relationship happening when the radius meets that point of tangency. They are perpendicular and they meet at a 90-degree angle. Easy peasy. Easy information that. All right, now I want us to take a deep breath. In, out. In, make sure you not take a deep breath with me now. Out. All right, we're moving into another little piece. Another little piece. All right. Now this is called the alternate segment theorem. Don't get lost, you know. Follow me, just follow me. So when you have this angle between the tangent and the chord, look on your screen and tell me what is happening before I even tell you. That angle that is formed between the tangent and the chord. What can you tell me about that angle? No, it is not 90 degrees. Remember, it's only 90 with the radius. This is not a radius, this is a chord. It is equal to the opposite angle in the where. Put on something on that. Was it Elena? Alyssa, somebody, a name pop up just now. Go ahead, sweetie. I see you raise your hand. Tell me.
The angle formed by a chord and a tangent is equal to the opposite interior angle when they share the same chord.
Yeah, go on in, a girl. Yeah, go on. You go on in. You go on in. So the opposite angle in the alternate segment from the same chord is equal. You see that? So if you notice that the tangent, the angle between the chord and the tangent is in the minor segment, the little piece down here, so you see that? That is the part that is below the chord. So that angle between the chord and the tangent is equal to the angle formed at the circumference in the alternate segment. Same chord, just different segments. And the tangent comes into play now. So it's only when the tangent is there, you know. If the tangent is not there, they are not equal. Remember, we already explored that this morning. But when the tangent is there, the angles in opposite segment on the same chord are equal. Only when the tangent is there. Tell me if I lose you or you're following me.
Please, can you repeat that?
When you have an angle, let me give it a name. As you can see with the arrow, but I'm going to give it a name nonetheless, and I'm going to call this angle Y. No, it's not there, so the angle there. That's not where the angle is. So right where you see the arrow is pointing right here, so I'm just going to shade it red, shading it red. So that angle that is formed between the tangent, here is my tangent. I'm going to call my tangent CD. So this end is D and this end is C. Calling my tangent CD. This angle that is formed between the chord, I'm going to put the name of chord here and I'm going to call the chord E and F. EF, the chord EF. Then the angle subtended by the same chord EF to the circumference in the other segment, and I'm going to call this angle W, they are equal. So angle W is equal to angle E. What I was saying, this only works when there is a tangent. If there is no tangent, then the angles in opposite segments are not equal. It is only applicable when there is a tangent. So let's look at the other angle that was there. So here you can see this angle here, 57 degrees, coloring it red. The angle 57 degrees, which is formed between the chord, and I'm going to call this chord XY, X and Y. Somebody saying something? Okay, no? All right, so here we have a angle being formed between the chord and the tangent, chord XY and tangent, that's 57 degrees. It is equal to this angle that I'm going to call A, which is in the opposite segment, the alternate segment. So it's the same chord XY. One angle is formed between the chord and the tangent on one side of the chord, and the other angle is at the circumference in the other segment of the chord. Is that clear?
Yes, Miss.
All right. All right, I think that is, I'm not going to touch this one. I don't want to confuse it. Let's try this question. I'm not going to touch that. Let's try this question. Let's look at this question. Because I know it's quite a bit of information. So let's try to apply some of the things that we would have learned thus far. Let's look at angle X. Talk to me about angle X. Look at it and look at it long and hard. So the diagram shows a circle with the points P, Q, R, and S lying on its circumference. And its center is marked O. RP is a diameter of the circle, and AB is a tangent to the circle at the point P. At angle APQ, we have 3x degrees. At angle QPR, we have 2x degrees. Angle RPS is x degrees. And angle QSP is 54 degrees. Now we want to know what is the value of angle X. Anybody want to take a try? Any wild guesses? How you get 54, Torian? Okay, I don't want you to give me an answer. I want you to give me your thought process. What are you thinking to help you to calculate the value of X? Oh, you got that 54 and that 36, Torian and Xavier respectively. How did you get those numbers? It's the dead emoji for me. It's the dead emoji for me. What were you thinking? Come, talk to me. Come, Torian, tell me what you were thinking. Rachel, tell me what you're thinking when you add those two numbers together. I'm going to give you a hint. Algebra is a part of your process. That's the hint I will give. Is that hint a good hint or you want another hint? Go ahead, Michaela.
Good afternoon.
Good
Okay,
afternoon,
so I'm
Freddie.
thinking that the 3x is equal to 54, and we would set that up as an equation and solve for x.
All right, so tell me, first of all, you have to tell me how comes 3x is equal to 54 degrees?
Because there is a tangent right where the 3x is, and the 54 is located in the alternate segment.
Yes, sweetie. Love that. Wonderful. That's one way. Excellent. That's one way. I'm looking and I'm seeing another way. Come talk to me. Three x plus 54 equal 180. How you get that, George? How you get that 3x plus 54 equal 180, George? 3x plus 54 plus 90. How you get that, George? I would love if you can open your mic and tell me. All right, DeAndre. Point Q is 90. How you got that, George? How is it that point Q? Is it point Q or angle Q? Either way, how did you come to that assumption? I'm listening, I'm reading or listening. Because the two, let me look. Because what radii from SP? SP is not a diameter, sweetie. SP didn't pass through the center. SP is just a chord. SP is just a chord. All right, I'm seeing DeAndre. Yes, DeAndre. What's the final answer? I see you, A. Smith. I see you. So, all right, here we go. So, whilst, I don't know why all of that came up at once. Whilst we, oh, okay, Aliana, by the time I bring up my something, here you go with me and you thinking the same thing. So, one way is to look at 3x being equal to the 54 degrees, because as I don't remember who spoke, said that the 54 in the alternate segment would be equal to that angle formed between the chord and the tangent. Very good. We also know that when the radius meets the tangent at the point of tangency, a 90-degree angle is formed, which means that there will be a 90-degree angle right here that suggests that 2x plus 3x would be 90 degrees. And we could simplify that, and then we will get to our 18. That should be 18 degrees. So either solutions, that would be fine. So 54 equal to 3x, or 2x plus 3x being equal to 90 degrees, either of those solutions would be acceptable. Did I lose anyone?
No, we are all here.
Is the Lumiere speaking for everybody? All right. What about y? Let me put in x, so we know that.
Sorry to interject. Kate said she said yes, miss. I don't know what she was referring to.
I lose your page, or are you there?
Kate.
Kate.
K-A-T, yeah.
Oh, Kate. Moses, what you knowing?
Oh.
You're good? Let me just say good. Good or not? Because these no and yes confusing me. Okay.
Somebody
Okay.
want a screenshot?
Yes.
Yeah.
Yes. Go ahead, sweetie. Remember, this is one solution. Kate, sweetheart, you good? Welcome. No. Tell me where I lost you. Turn on your mic and tell me where I lost you.
Hello, can you hear me?
Yes, I can. Yes, I can.
Miss everything.
You know I don't like when you tell me everything.
Miss, start over.
Okay. Give me 1 second. All right. So let me get this off the screen, and let's start over. All right, so who was the person who gave the 54 being equal to 3x explanation earlier?
Miss.
You want to go again for Kate?
Okay, miss.
So I was saying that the 3x, there's a tangent right beside the 3x angle. So it would mean that the 54 in the alternate segment would be equal to the 3x.
So,
And
all right.
if we
Sorry.
put 3x equals to 54 and solve for x, would get x equals 54 divided by 3, which is equal to 18.
All right, so before we get to the solution, so Kate, we looked at a theory just now that says that when you have an angle being formed between a chord, and in this case, the chord is QP, and the tangent, which is now 3x, this angle here is equal to the angle that is formed at the circumference on the same chord in the opposite segment, which would be 54. So if you notice the angle at S, which is 54 degrees, it is formed on the same chord QP. See it here? QP. So this angle 54 and the 3x are equal. That's a theory we just explored. So if those two angles are equal, we can use the process of algebraic reasoning. We know that 54 is equal to 3x. And so we can simplify by dividing both sides by 3, 54 divided by 3 is equal to x. And then we know that 18 is equal to x. The angle is represented by the same x. So x is 18 degrees. If you use that method that Michaela explored. Is that method clear, Kate? Tell me if you have that one. Okay, great. Then the other method that could have been explored, let me clear my screen. The other method that could have been explored is the method that refers to the fact that when a radius, here represented as OP, meets the tangent, they meet at a 90-degree angle. They are perpendicular. So what that suggests then is 2x plus 3x would be equal to 90 degrees. Can you appreciate that?
Yes, miss. But what about that little section?
What
Miss,
little
is that not-
section? Right
miss,
here,
that-
wait, let me use a different color. Let me use a different color. Erase. Are you referring to this little section out here, sir?
Yes, miss. Is that not included in the 90 degrees?
It is included.
Oh.
What you are mistaken is that when the radius meets the tangent is not just the angle in the circle that is 90, no. Is all of, so it would be everything right here that includes that little piece that would be 90. So that's a very good question that you asked, and I want to reiterate that point that students, this 90-degree angle is not only for the circle, it is all of the angle that is formed in between the radius and the tangent that would include any outside angle outside of the circle. So I'm very happy you said that, Kate, just in case somebody mistook that, right? So then by the process of algebraic reasoning again, we know that 2x plus 3x equal 90 degrees because the theory says that when the radius and the tangent meet, the angle that is formed there is 90 degrees. And then we just simplify 2x plus 3x equal 90 degrees. 5x equal 90 degrees. We want x by itself, so we divide both sides by x, which would give us 18 degrees. You're on the train with me still?
Yes, Miss.
Awesome sauce. All right, so I'm seeing Daniel asking, why can't angle RSP could be 90? So RSP, and I'm going to ask you, Daniel, who says that RSP is not 90? But I would like to point out that RSP is all of this angle. So it would be 54 plus the other piece. Who said it wasn't 90, Daniel? Don't overthink it, man. Don't overthink it. All right, is everybody on the train with me? Did I lose anyone? Anybody came off the train? No, all right, good. Remember, you know, no man left behind, and don't be afraid to say you don't understand, you know, because I don't want you to leave. And you say, boy, I'm not come back and no more of them something here. You're seeing 390-degree angles, Daniel? Where's the third one? I understand, Moses. I understand. Just don't overthink it. Just take your time and go through. Just don't overthink it. One thing at a time. All right. Here we go now. Angle Y. This one is pretty easy. Angle Y is so easy. Daniel actually helped you with a piece of it. So what's the final answer, DeAndre? Okay, very good. Thank you for that correction, ma'am. So let's include our information that we just, so we know that this here is 18 degrees. We worked that out already. And we know that because of DeAndre's question, why is S 90 degrees, by the way? Can somebody tell me why is angle RSP 90 degrees? This what kind of cards you are joining, DeAndre? Come on, I never tell you any such thing.
Miss, angles at a center is twice the angle of the circumference.
That's one reasoning, and we know that the angle at the center is
180.
Because it's a
straight line as well as a diameter.
Very well. Or we could, what about the other reasoning, which actually comes from your reasoning, but just in case we don't remember that part, there's also another explanation why it's 90 degrees. Angles in the semicircle. You can't just say it like that in a Miss Mercedes. Thank you very much, DeAndre. angles formed by a diameter or from the diameter at the circumference will be 90 degrees. Thank you. All right, so what we got for y, are we all agreeing that y is, what's the number we're agreeing to? 72 degrees, lovely.
Excuse me, miss.
Mm-hmm.
Miss, you lost me again.
Did I lose it based on the explanation that's on screen? Or did I lose it in general?
Miss, in general.
Okay, all right. So just like all the other questions, we have more than one way of working this question. Let me take off what is on the screen. So angle S, can you agree that angle S is 90 degrees?
Yes, miss.
Good. And we know that angle X is 18 degrees. That's clear, right? Right? Is what talking to? Is Kate?
Yes.
Who was talking to me? Where you gone? Hello? Hello? Who was talking to me just now, guys? I can't help you if you're not talking back to me. Other than the person who was speaking to me, did I lose anyone else? Are we all on the same train? Did anyone come off the train? Marriott, is it that I lost you or you're good? Okay. And Daniel, you're on the train, and Jade, you're on the train, right? The train to a grade 1 in CSEC math. Just to be clear, that's where we're heading. All right. So, okay, let me go with the explanation nonetheless. So there are two ways that you could have worked this question, or maybe somebody else think of another way, but I'm only seeing two at this moment in time. We know that angle RSP is 90 degrees by virtue of the fact that it is an angle formed at the circumference subtended by the diameter RP. So automatically it's 90 degrees. Okay, great. We know what X is because we worked that out already. We can also see that angle Y is formed within a triangle, and that triangle is P or RPS. Any way you want to call it. So the triangle there, right? We also know that the sum of the interior angles in a triangle sum to 180 degrees. So since we know two angles already, we can simply say, oh, that's not what I want. I want the eraser. We can simply say 180 subtract 90 plus the 18. Can somebody tell me what is 90 and 18, please? How much?
Miss 108.
Okay, 108. And when we subtract 108 from 180, we get
72.
72 degrees. Oops, I am writing 7 squared. We get 72 degrees. Go ahead, Danny.
I'm a little confused. I understand how we got to the 72 for y. Miss, but I wanted to say, why couldn't we use 2x, the same alternate angles on a line? Miss, if we just do the 2 times the 18, which would have been the 36, why wouldn't y be equal to the 36 instead of the 70?
What alternate angles are you making reference to?
Miss, y and the alternate angle would have been 2x.
2x, okay. Alternate angles are formed between what and what? Talk to me, Nadir.
I'm not exactly sure.
Two parallel lines and a transversal. That's the only time we have a conversation about alternate angles. Are there any identified parallel lines on our diagram?
No.
No. So we couldn't use that theory.
Okay. So as long as I could like could write the z. Once there's a z, then you can do the alternate angles, right?
No, it has to be two parallel lines, and the parallel lines must be identified. So either the stem of the question, which is really the worded part of the question, tells you that the line segments are parallel, or you see the arrowheads on the diagram. Daniel, your microphone is open. So if nowhere in the question you see that the lines are parallel, then you can't use that. All right?
Right,
And
I understand.
Okay, awesome. But let's even verify to prove. So we know that the angles in the triangle should sum to 180 degrees, right? If we used 2x and the alternate angle theory, 2x would be 2 multiplied by 18. 2 multiplied by 18 is what, 36? Am I correct? Is that 36? Somebody tell me if I'm right now.
Yes, it is.
Yes, it is. And 36 and 72 are two very different numbers, which means that we couldn't have used that. All right, so that's one method. We could have looked at the 90 plus the 18 and subtract from 180. The other method we could have used, which is in black, the fact that we know that RSP, that angle there that is right here, is 90 degrees. We know that then the other two angles must sum to 90, because if one angle alone is 90, that means that out of the 180 degrees that must be shared between the three angles, we only have 90 more degrees to share between these two angles. So that means that x plus y must be equal to 90 degrees. We already know what x is, which is 18, and we simply simplify and find the value for y, which is 72 degrees. So either strategy would have been fine. Sorry? Somebody saying something? Somebody saying something? All right, so the final question is 156, and I know your brains are tired. So we're just gonna do the final question, which is Z. And Z is pretty easy again. Anybody can give me the answer for Z? We have more than one ways we can work out Z. Somebody want to open their microphone and tell me what you did to get Z? I'm seeing numbers in the chat, but I am not seeing any explanation. Xavier, would you like to tell me how you got 72 degrees?
Yes.
Jade, go ahead. You want to tell me how you got 72? You got 72 as well?
Yes.
I'm barely hearing you. Is my something is the problem?
Yes, Miss, I got 72.
Oh, guys, are you hearing Jade?
Barely hearing her.
Barely, right? Speak up a little bit more for me, sweetheart.
Miss, I was saying that first of X is 18 that we found. So I used the big triangle S, Q, and P. So X is 18, and then I find 2X, which is 2 times 18, which is 36. And then I add those plus the 52, and then minus it from 180.
All right, that is one way. Thank you very much. Anybody else would like to open their mic and share? Tyrese, you want to open your mic and share? Oh, you got 72 and 72 what, sir? Dumpling? 72 pairs of socks, 72 meters.
Miss 72 degrees, Miss angles in the same segment.
Small boy.
Okay, angle in the same segment. You don't finish right there.
Miss
not
are
just-
equal.
And what else? The in the same segment. What else? It's not just the fact that they're in the same segment. You have to add something else to that.
This is because they're on the same chord.
The same
Chord.
chord. Same chord, same segment. Boom. Because you already knew that Y is 72 degrees and Y and X are tending from the same chord in the same segment. Go ahead, Samsung SMA032M. Go ahead, darling. So why you raise your hand and gone? Thank you, Yendi. All right, so either solution that you used would have been fine. All right, I'm not gonna go through those questions with you. But let me. But I'm going to say thank you so very much. I enjoyed my time with you. I hope you enjoyed your time with me. And I hope I did not stress you out too much. And I hope that at the end of the session, you can say that you learned something. Mr. Limi is going to put a link in the chat. I'm asking you kindly to click on the link and fill out the evaluation form. We need your feedback such that when we have our next workshop, we are better able to serve you. You need more time? Me too. So click on the link.
Ms. Sherelle,
Yes, dear.
look, just a quick question. I saw something about Tyrese Irving about Miss Angles and Z are equal. I know you said you're finished, but was Tyrese speaking to the angle Z? Angles, Miss Angles and Z are equal, Miss. Was that Tyrese, was that about the angle Z? Finding what is the value of the, because I wanted to make sure that he got that idea where you talked about the fact that you must have a pair of parallel lines and a transversal.
Okay.
So
So
Tyrese,
remember,
go
if
over
you
that,
are
please,
talking
miss.
about Z angles, U angles, those are co-interior, X vertically opposite, alternate. Any of those angles, you must have a pair of parallel lines and a transversal. If you don't have any parallel lines or transversal, you cannot use those theories or those properties. Okay? Remember the link in the chat?